Hey, and welcome to a lesson about Learning Target 101.2 in PPBL 2024. In this lesson, we're going to cover compiling the PPBL Faucet validator. You saw something similar to this in the previous lesson, but this time we're going to do it from a language called Aiken. And you can see an outline of this lesson here on the page, and I invite you to follow with these steps. And that's exactly what we're going to do today. Okay. Now, this video feels a little bit different from the last one because this one is being recorded at our live coding session, which meets every Wednesday at 14:30 UTC. If you're interested in joining up for this meeting, you can find all the details you need at plutuspbl.io. Click on live sessions on the top of the page. Whoops. And you can navigate to our calendar where you can find links to meetings like this one. You can see a Zoom registration link, for example, right here. So what's Aiken? Well, it's an alternative to Plutus TX. And I don't know, has anybody else here heard any mudslinging between Plutus TX and Aiken camps? Or has Aiken already won? Is everybody just going the Aiken direction? Maybe. All right. There's an ongoing debate about which of these languages is better or which one people should use. And one thing you got to understand about this course is that we want you to decide for yourself. If you want to go out there and participate in the debate, that's great. We're going to give you evidence for either side, but we're not going to try to tell you what to think. Okay, that's up to you to decide which side you're on. But hopefully this course gives you some evidence about what you like about Plutus TX and what you like more about Aiken and vice versa. So we're going to go step by step through the process of running Aiken. And one advantage that's really clear about Aiken is that it is easier to set up an Aiken dev environment on your own computer. Plutus TX has a large amount of overhead. And we've met a lot of people over the last few years for whom that can be a blocker to getting started. And if you've ever heard people saying, Plutus is too hard or Haskell is too hard, a lot of those people, what they're talking about is just that setup step, just getting started. So score one for Aiken here on the process of getting started, but also score one for the entire Cardano developer community, because now we have tools like Demeter that make it much easier to get started using Plutus TX. And we encourage you to take a look at the previous lesson if you haven't done that already. Now, there are resources on Demeter that you can use to run Aiken on a virtual machine and access in your browser, just like we did in 101.1. But I really do encourage everybody to try to set up Aiken on their own device. And to do so, you can follow the installation instructions that are linked right here. There's a few different ways to do this. The Aiken team provides a tool called AkeUp. This is a little bit like NVM for people who are familiar with that on node development. It just manages your versions of Aiken for you very quickly. So you can install AkeUp and use that. Or you can follow any of these processes right here. Aiken can be installed via NPM, Homebrew, or if you have a Rust toolkit installed on your device, the Rust package manager is called Cargo, and you can use this one. Also, if you like the Nix approach, if you're coming from Plutus TX development and you have Nix set up, for example, you can use this option right here. Now, there's another thing to understand about this Plutus PBL course. That's all I'm going to show you about installing Aiken. And we're going to leave it to you to read this documentation and try to get it working. If you do get it working, you'll know that you were successful because you'll be able to jump over to your terminal and type Aiken dash dash version. And you'll be able to see that the current version of Aiken is installed, which as of today is version 1.0.26-alpha. We can confirm this on the releases page for Aiken here on GitHub. If you get stuck at any point, there's a few options. We hope that you'll reach out on the Gimbalabs Discord server, or that you'll drop by one of these live coding sessions, okay? Even though we're not going to hold your hand every step of the way in this video to show you how to install Aiken, if you get stuck, we absolutely want to help you out. And that's a pattern you're going to see over and over again in this course. Our goal is to provide little places where people might get productively stuck. Teachers like to call this productive struggle, okay? A struggle can be demoralizing if it lasts for a long time, but we all know this, right? To learn really important lessons, a little bit of struggle can come in handy, okay? We want you to get stuck, struggle a little bit, and then we want to help you get unstuck. So let me switch windows here. And for the rest of this lesson, I'm going to be following the documentation that's here on the page, but I'm going to be doing so from my VS Code window. Let's jump over there. Share Visual Studio Code. All right, right here, you can see a couple of things. First of all, let's just make sure that I do indeed have Aiken installed. Aiken dash dash version. And you can see right here, I have version 1.026-alpha. Not sure why there's an unknown release tag right here. I have to double check on that. But as of today, this is working for me. Now I've also already run the command git clone for this repo. You'll find the link below this video in the lesson, okay? So I've already run a command that looks like this. Let's just grab it. Okay, I'm not going to run this again, but this is what you would want to do. Git clone the example repo. And once you do, you'll be able to CD into it, okay? So I have a couple of projects on this device. I just git cloned this one, and here we are. Now in here, there's only a couple of directories, and I want to look at really the only one there is so far, PPBL Faucet. We're going to add other examples to this repository later in the course, but for now, this is the one you need. So let's CD into that one as well. Great. Let's also look at that directory over here. This is a standard and pretty minimal Aiken project setup. I have an aiken.toml file that provides some metadata and some dependencies about the project. If you're familiar with JavaScript, for example, this is kind of like your package.json file right here. And it's accompanied by a lock file that's similar to lock files that you could find in many other platforms, right? So if I have a package JSON file in JavaScript, I might have a package JSON lock file as well. README, git ignore, standard stuff. And the most important thing to see is this validators directory right here. If you took a look at the prior lesson, 101.1, you're starting to be familiar with this word, validators. A validator holds the code for how transactions can succeed or fail on Cardano. More specifically, it helps us write the custom rules for how individual UTXOs can be unlocked from validator addresses. Now, there's a lot more to talk about there. And in the next module, we're going to jump in to transaction building, which is going to help a lot of these pieces come together. But for now, I hope that on your own time, you'll take a look in detail at this validator. Try to compare it to the code we looked at in the previous lesson, because you'll find a lot of similarities. You'll find datum that looks similar, a faucet redeemer that looks similar, and you might be looking for something called faucet params. If you're really paying attention, we won't see those exactly the same way. They don't get a name in this case, but we can just put them right here, okay? And we could extract these out and make a type as well. There's a few different ways to do this, okay? But for now, just notice that the parameters get passed to this validator function as arguments. This looks familiar from a lot of different languages, right? Two comma separated arguments inside the parentheses of our function call. What's in the body of this validator is a function called PPBL Faucet. We could call it anything. And it takes three arguments that look very similar to the faucet we saw in the previous lesson: datum, redeemer, and context. We're going to look at all of this in depth over the next few lessons, but for now, just recognize the similarities between this code and what we've looked at previously. I'm going to skip over a lot of these details because this is what we're going to, again, dive deeper into soon. But at the very end, I want you to see that just like in Plutus TX, there's a set of Boolean statements that must all be true in order for this validator to succeed. Some of these match the Boolean functions that we looked at in Plutus TX in the prior lesson, but some of them are a little bit different. And those details start to get really interesting. When we start building some transactions in the next module, we're going to look at some of those details in depth. But just like in the last lesson, before we can even think about transaction building, we have to be able to compile this code right here into a format that can actually be used on the blockchain, right? If I tried to upload this PPBL Faucet.ak file to the blockchain, it wouldn't do me any good. First, I have to compile this code into a byte string format, right? This can be translated into a CBOR string, which is a type of byte string that encodes the logic of this validator. And you might often hear the term UPLC, untyped Plutus core, when it comes to on-chain code. And this is really interesting. No matter what language we're starting from, Plutus TX, Aiken, or as you'll see in the next few lessons, Helios and PluTS, all of those languages compile to the same target. The compilation target is UPLC, untyped Plutus core. And this is, right, the encoded format of that is what we're able to use on the blockchain itself. How do we get there? I'm going to open up a terminal window, and I'm going to open up my file explorer because we're going to be able to watch a couple things change over here. First of all, anytime you want to, you can run Aiken check just to type check your code, and you can see that this code has no errors and no warnings in it. That's a good sign. Great. A wonderful thing about Aiken is that the error messages and the warnings are really helpful. They actually have some personality, and they suggest ways for you to try to fix those errors and those warnings. And we'll take a look at those in a couple of lessons really soon. For now, good. We're happy that Aiken check worked. Now let's run Aiken build. What this is going to do is take our source code and output a new file right here called plutus.json. This is called a blueprint file. It has some metadata about the contract. Here's the title. Here's a description. Right? We have the version and which version of Plutus. We have which version of Aiken. They're calling Aiken our compiler because that's what's getting us to our target, which is Plutus v2. And then we have a list of validators. Cool. We got some validators. We've got some helpful definitions in the rest of this file. Let's look at those validators. There's only one. Okay, so validators is a list because a lot of applications will have multiple validators. This one only has one. What's the title of this one? PPBL Faucet.PPBL Faucet. Very good. Then we've got schema for these things called datum and redeemer. And if we scroll down below to see these definitions, maybe if you've been following along closely, these definitions will not surprise you. The type of faucet datum included a withdrawal amount, which is an integer, and a faucet token name, which is a string. Here we call it a byte array for reasons that are a tiny bit beyond the scope of this lesson. We're going to talk more about this when we start building transactions. But for now, this is the way to represent a string when we start writing on-chain code, okay? We have this thing called redeemer that also matches the type of the faucet redeemer. We've got a sender pub key hash and an access token name. We also have compiled code already, but that's a tiny bit of an incomplete story. This compiled code is only going to work if we first apply these parameters to it. And in the previous lesson, we showed you how to apply parameters to a validator in Plutus TX. Now we're going to look at this a slightly different way and see one way to approach this in Aiken. We've got two parameters. They're the same parameters from last time. We need the symbol of an access token and the symbol of a faucet token. Then we've got to apply them here. Now, I said, will this work? What do I mean by that? Let's try something here. Aiken Blueprint provides us with a couple of different commands that we can use to interact with this blueprint file. Okay, and once again, this file called plutus.json is called our blueprint. We can try to derive an address from this, a policy ID, a hash, or we can try to convert this into another format. You're going to learn a lot more about validator addresses when we start building transactions. But just as an example, watch this. Aiken, blueprint, let's just write address and see what happens. Notice that I got an error. Blueprint address parameterized. I couldn't compute the address of the given validator because it's parameterized by two parameters. Exclamation point. I told you, these error messages, they've got some personality. I can only compute addresses of validators that are fully applied. Okay. And this is missing two of them. Applying parameters changes the validator's compiled code and thus the address. And that's why I need you to apply parameters first using this command. Okay. So I see that that doesn't work. What about another one that we're going to use in just a minute? Am I able to convert this to another format? That's interesting. So I can see a file that looks kind of similar to the output file that we got in the previous lesson. But once again, this is not going to work because it doesn't have the parameters applied. And that's something we can look at more over the next few lessons. Let's see if we can apply parameters to the point where this address function works. Okay. And so we have an option called apply right here. Let's try that. Aiken blueprint apply. All right, it prompts me right here in my terminal for an access token symbol. Okay. Let's switch windows for just a second. I'm just going to go over to GitHub and open up the code that we were looking at in lesson 101.1 so we can see these same parameters are here. So here's the compiler that we used for the faucet from Plutus TX, and these parameters were applied at this function step, right? We can write a function for this. You could actually write a function that does this as well for Aiken, but I just want you to get a feel for these different ways, right? I want you to see that a validator can be partially compiled without parameters. A lot of really interesting stuff is going to follow from here. And so we're already starting to look at our different options. But this is what's interesting to us. The access token symbol is right here. The faucet token symbol is right here. Let's just copy and paste this access token symbol over to VS Code. And watch how the Plutus.json file gets updated. Watch closely here. I'm going to try to minimize my terminal so you can see. Watch these parameters and watch the compiled code when I paste this policy ID and then press enter. We're going to be overwrite. Oh no, hold on, wait a minute. I forgot to do one thing. And this is in the lesson, you'll see this. I shouldn't have written Aiken blueprint apply. I should have written Aiken blueprint apply -o for output and then Plutus.json because I want to overwrite the existing blueprint file with the results of what I'm about to do. Okay. All right. Now we're going to be able to watch this file and we're going to be able to see it change dynamically. Same prompt. Give me an access token symbol. Paste it here, and I'm going to press enter. What just happened? Well, it says it applied this. Now, it says it applied 581C903. Is that exactly what I typed right here? It looks pretty close, but do you notice the difference? A couple extra characters at the beginning. That's kind of interesting. All right, keep that in mind. We'll talk more about that a couple weeks from now. But also notice up here, now this blueprint file, the compiled code is a little bit longer than it was a second ago, and there's only one parameter left. Now, I still can't run Aiken blueprint address. I still get an error, but now it's only missing one parameter. So let's try it one more time. Let's run blueprint apply on this file. Last time we were prompted for the access token symbol, but watch what happens this time. We're prompted for the faucet token symbol. I'm not going to share screen. You guys just saw this in my browser that we had the faucet token symbol in the Plutus repo. So I'm just copying and pasting from there. We can apply this. Once again, watch the parameters, watch the compiled code, and also watch line 37, the hash. Ready? Okay. No parameters left. Compiled code is even a tiny bit longer, and the hash was just updated. Now that we have no parameters left, let's try this address command one more time. Aha, this generates an address that can be used on the blockchain. How do you use this address? That's what Module 102 is about. For now, the work is done. We have a compiled validator with parameters applied from Aiken. So finally, if I run Aiken blueprint convert one more time, I'll see something that might look familiar once again from the previous lesson. And what I'm going to do here is I'm just going to create an output folder for myself, output, just like I had in my Plutus TX repo. I'm going to make a new file here called Aiken PPBL Faucet, and I'm going to call it .plutus. And I'm just going to copy this right here into that file. Now I have a Plutus script that can be used on chain with the byte string right here that looks very, at least in terms of its shape, it looks very similar to the one we see here. Plutus examples, output, my faucet script.plutus, and the text isn't wrapping here on this version, but you can see that the shape is the same. All right, this is what an on-chain Plutus script looks like, and this is a file that we can have all sorts of fun with in the next module. Anybody have questions about that? Thanks for hanging out for that. I appreciate the chance to do this live. What are you thinking?